Right, so we are top of the hour. So we are going to get started with the official content. We've kind of already been dabbling in two-wire, and the subject for today is two-wire. Let me share my screen and we will get this thing going. Sorry, I was juggling in the background here. So hopefully you are just seeing my introduction screen introducing today's special guest, Noé Cruz from SiteOne Green Tech. Noé, thank you for making time for us. I love having your expert opinion on this episode. We are excited to talk about the new HydroPoint OptiFlow H2O 200 station controller. And this is a unique discussion because it is a feature set. The 200 station is new, but the OptiFlow controller is not new, and the H2O controller is not new, but it feels new because we used to have the limitation of 96 stations, which kind of started off in our conventional wire world, and all of the software was built around a 96 station limitation. Because we have that 96 station conventional option, it made sense in all of our software to stop there with two wire. But we see in the marketplace the need for more than that. Can you talk a little bit about your experience with two wire and why our engineering team felt like they needed more than 96 stations?
Yeah, so through my experience, I would say 99% of two-wire installations that I've worked on are averaging 120 to 150 stations per controller. And this is dictated most by a landscape size, of course, as well as understanding the tech side of it. How large can a landscape be? How long can the two-wire path run to accommodate proper voltage to said decoders? Once landscapes go over 200 stations, 99% of them go into multiple controllers, which can accommodate the electrical side of that hydraulic water management. So that being said, it's a combination of marrying the electrical capacity of a controller as well as the hydraulic size of a landscape.
So when you're talking about that, what I hear you saying is we definitely needed more than 96 because your sweet spot is right in the 120 to 150 range. But because of the limitations of what else goes in the ground, the wire run and the gauge and all the other components, 200 stations really is more of an upper limit in realistic management. Is that what you're saying?
That's exactly it. So right now, taking a brief moment to understand two-wire decoder controllers, let's first start off with the power. So here in America, we have 120 volts AC operating at 60 hertz, that frequency. That being said, an irrigation controller's transformer gets in 120 volts at 60 hertz. This controller has a 35 volt AC output, also at 60 hertz. Thus, decoders, from my experience, need at least 29 volts to function properly in the field. So consider your wire gauge voltage drop over linear feet to stay over, say, 28 volts in the field for this length run. So 12.2, we can run an easy 3-ish miles, 14.2, maybe a mile and a half. And then we also have to take into consideration linear feet of a two-wire and all of the upsweeps, downward continuing. As part of that, 3 miles, a mile and a half average range for two-wire. So once we understand the electrical side, that is gauging more or less the design side for landscapes at an average of 120, 150 stations.
That makes a ton of sense. Now, on install, we were talking about the looped concept, looping that wire back on itself. Do you have an opinion about whether that extends your range or whether that's a good design choice or not?
Define looping. What do you mean by looping?
So where you're getting where it's wired into the controller from both sides. So you're getting electrical signal from two sides in a looped configuration.
That is an excellent installation method. Now for the design side, for maintenance, for most contractors who say are not totally comfortable with two-wire, let's just say you have your controller on the furthest say the west side, and then you can make a loop that runs all the way around to the east side and comes back to the west side. The benefit to the electrical capacity of looping a 2-wire system is you can easily double the wire length, maybe just maybe 2.25 times the length of a single run. But also bear in mind, what's interesting, a great question. Bear in mind that by the time you complete that loop and you double that length, you get the same distance coming back. So if you're to say take 3 miles and go possibly 6 miles, that's 3 miles out and 3 miles back. So it's hearsay what works best. I personally prefer end runs, especially for earth grounding and line surge protection, surge arresters, which we can talk about as well. Surge arresters, lightning protection is critical for most landscape designs. Thus, end runs are the easiest to apply lightning protection to our decoder systems.
And and our corporate philosophy is much the same as yours, if I heard you right. Like, while it is a capability, it's not always a best practice to have that looped configuration, right? Because unless you're an expert, because the information and electricity can be traveling from either side, it can mask a problem and make it harder to find. It makes troubleshooting more difficult in that configuration unless you know how to go about it. So that's one reason that I don't love the looped wiring configuration, just because it adds steps in the field to troubleshooting, and anything I can do to make that easier for guys, I'm all for.
I think that is it. Is it wrong? No, it's subjective to the design, subjective to the site. However, in most cases, it's not necessary. And also it's critical to have, so you have a controller on the west side. On the far east side, we normally suggest installing pedestals with hard switches to be able to cut 2-wire lengths in half with a simple switch, to be able to quickly diagnose the 2-wire system, because every 2-wire controller, back step a little bit, every 2-wire controller has to manage a milliamp load. 1 milliamp is 1/1000th of a full amp. Thus, we sell at SiteOne milliamp clamp meters to measure the flow of milliamps. And what's most critical for any design, every 2-wire controller installed in the field, every contractor should know what is their expected milliamp load on that controller when it's finished. So every single station decoder installed has an average of a 0.7 milliamp load. Every sensor decoder, right around 6 milliamps per sensor decoder. Line surge protection decoders, 0. Every contractor must know their sum total to know what milliamp load to expect from the controller. Thus, if you have end run 2-wire paths, you can easily diagnose. Let's just say I have 10 single station decoders beyond this point. My milliamp load should be 0.7 times 10, 7. If you see more, you have a short. You see less, you have a disconnection. Easy to navigate.
Absolutely. And shameless plug, if you look back on our 2-wire troubleshooting episode, we had a great contractor on, Justin Shelby. We talked about calculating the load on your 2-wire path, and most importantly, like you were talking about, having the right tools for the job. So having that milliamp clamp meter and understanding how to test the load on that 2-wire path.
And then going beyond that, having the right tools for the job, consider the Armada Pro 93, measures milliamps. The new Armada Pro 95i also measures milliamps. What's the difference? The difference is the Armada Pro 93 cannot properly measure milliamp load on a 2-wire system that's live. What I mean by live is the 2-wire controller it's on and it's putting out voltage communicating to decoders. Whereas the 95i, even with the frequencies enabled for communication, will still read the milliamp load.
Well, I didn't know that. I know that I had to upgrade to the 95i, but I didn't know that that was the reason I had to. I was just told by the Armada guy.
So most multimeters, electrical multimeters, will measure voltage on a 2-wire system, but you're going to get numbers that jump around like crazy because of the communication going through the 2-wire path. I've been using the Fluke, the T5-600, been using it internationally, systems that operate at 60 hertz and 50 hertz. And they've never failed at my Fluke T5-600 will read the voltage even with frequencies enabled. So it's about knowing your tools, knowing your system, and then using those right tools to properly identify problems.
Absolutely. So I want to bring this back to the 200 station conversation. One of the things I wanted to highlight with you here, I want to share my screen. Again, the thing that I like about our 200 station is that it is the same. It is virtually the same as every controller, right? We're taking big steps that appear as baby steps. So we're not putting out a new controller or new software or anything that is going to change the management experience of the WeatherTRAK user. So if I take you to this new demo, this is my 200 station that I have sitting here next to me in my basement. And you can see that if I go in here, it is just the only thing that has changed to the manage page is the ability to go all the way to 200 stations. So if I save this, and right now this is programmed as a 3-station controller, and I'll show you why in a second. But one of the big tasks of updating for the 200 station was going through the interface. We had all of our stations were a 2-digit code. So we stopped at 96. So we never needed that third column for numbering. And going through and changing all of the interfaces and all of the reports to be able to satisfy that was one of the heavy lifts. But really, making that happen didn't change the management experience at all. It really just made it expanded capacity, but everything manages exactly the same. And to me, that principle is a super important one, right? We're not rewriting any books. We're not rewriting the management experience. It's very easy to adopt for the users. Can you speak to that a little bit?
Yeah, it's easy to adopt for the users. And as far as running up to, say, 200 stations, just like I was just describing the electrical management, the management of the lamps, consider running up to 200 stations. Imagine running one station at a time. This controller can run multiple stations simultaneously in the flow management feature. So just like 2-wire, if we know what load to expect for the decoders, we know what total sum load we should have on the controller. Same thing goes for the irrigation side. We must know this controller can connect up to 4 different points of connection to water. I call them POCs. So this controller can hydraulically flow manage up to 4 POCs running multiple stations simultaneously. And as we all know, luckily for the decoders on the electrical side, we know what load to expect given their production.
Yep.
Systems with irrigation stations, the irrigation controller must first learn the flow for every station. We program into the controller the peak flow capacity per point of connection to water and let the controller go to work. You can run stations simultaneously by priorities, by number, and this is where the controller shines in that it does the work for you. You don't have to guess how do you accommodate water windows when you just simply learn your peak flow capacities, learn each station's flow, and let it go to work.
And that is one thing that I definitely want to touch on. It skipped ahead, so I'm going to just go there with you. So one of the things that users need to know about the new 200 station is that it comes standard as an OptiFlow controller. So if you are used to using WeatherTRAK in the LC or the Pro 3 format, the OptiFlow has an added little bonus of what we call flow optimization, which is what Noé was talking about. We have the ability to go in and manage the hydraulic structure of the system, know how many gallons per minute our main line can produce, and know all of the little nuances about how it's sectioned off in different sizes and different capacities, and then really optimize the irrigation schedule to keep that main line flowing at its capacity and push as much water as is safe to run through that system to minimize the amount of time that it takes to run and manage a site's irrigation program. So what we see here is an OptiFlow program that is on a much smaller controller, but this is my demo that has handpicked the stations that can run together to keep that main line flowing at its capacity. Noé, can you tell me how you think that this is an important feature on a controller where you're managing 200 stations?
Yeah, so basically consider most, let's say here in the Bay Area, in California, most commercial sites running 200 stations almost always have a booster pump. Just like the electrical load of decoders, the hydraulic capacity of a system, consider a pump. An irrigation pump has to run within its flow range. If it's, say, a VFD, it has a range. If it's a fixed speed, it has one exact number to stay pretty close to. That being said, the system will optimize flow to also manage the load on a pump, to compress the water window, to let that pump run as efficient as possible without trying to push too much water or not enough water. What I'm trying to describe is the system connects all the dots to optimize flow for any site. Consider if you don't have a booster pump, you're running potable water, let's say running a 1-inch main line with a peak flow capacity of 40 gallons per minute. How are we going to run everything? Well, you don't have to guess. If you let this controller learn the flow, run, optimize, you'll know pretty quickly if this can accommodate that flow or not. My point is this system closes all the gaps, so there's no guessing. Somebody can log in and quickly see what's going to happen.
Absolutely. And I think beyond that, it really facilitates ease of management type of questions, right? So when you're talking about managing 200 stations on a controller, it is mind-blowing to most of those guys that are new to irrigation or new to two-wire, because they're used to topping out at 48 stations, which is already a lot, right? It's hard to get water windows managed on a 48 station controller. And when you multiply that by 4, the challenges only get deeper. And so we decided to make OptiFlow standard on this so that we can facilitate we can get that out of the gates. We don't have to worry about juggling start times and programs and making you own all of the optimization of that schedule or the management of that schedule in a way that gets everything watered in the water windows and doesn't overtax the system, right? When you say connecting all the dots, that's what you mean, right? You're taking all of the restrictions and all of the technical side and putting it all together in one simple format.
Can you go back to the dry run window?
Yep, for sure.
So working with many cities, to stop right there. Don't move. So right here, we're going to see OptiFlow. We're seeing a 20 gallon per minute and a 70 gallon per minute, 2 stations running, stations 1 and 17. Consider you're managing 100 controllers. All 100 controllers have 100 stations. That's 1,000 stations. Imagine managing that site, let's call it a city. Instead of getting calls for dry spots or floods or broken sprinklers or geysers, the system can send out alarms so that, let's just say we have an irrigation manager with techs. They can know simply by looking at their alarms report with this system to know where to send a tech to fix what. Go to station controller X, station Y. We had a high flow, what's going on? What I love about this system is that it optimizes not just the design side, the installation side, the maintenance side. You kept bringing maintenance to the table. Consider, instead of having to guess where you have issues or going looking for issues, the system tells you exactly where they are.
Exactly. And that's really what, when we talk about smart water management, that is at the heart of the conversation for us. It's not just applying the right amount and eliminating water waste, but it's giving the manager the right information to make good decisions and minimize not only the maintenance time, but the downtime of the irrigation system or the water loss that happens because of infrastructure failure.
Right, exactly. Continuing on to this topic, just briefly while we're looking at this right here, consider, move your mouse up and right.
Up and right.
Right there. So consider your water window. Let's pretend that your water window ends at, let's say 2 a.m. What I love about this system is the system will also compress all stations so that every station will water. You might get an alarm. Your water window is too short. However, everything will water. Unlike others whom will take that, whatever's after 2 a.m. and try to stack it onto the next day, getting potential dry spots, this system will compress everything so everything waters at least a percentage to fit that water window. And again, notify the user of that issue. My point is connecting all the dots to properly manage any size site from 1 controller to 1,000 controllers.
Exactly right. All right. So that is anything else on the OptiFlow side of it?
That is the premise of OptiFlow, is water management. First, we have to let the controller learn the flow for every station. Then we let the controller optimize its learned flow per point of connection water.
Yeah, exactly. And the reason that this is important to the conversation about the 200 station 2-wire is that this is the first controller that comes out of the box with OptiFlow enabled. So it is something that you have to be ready for. It's not, the OptiFlow isn't new, but it might be new to you. But all that is required is on top of the normal steps of setup, on top of what you're used to with WeatherTRAK, soil type, sprinkler type stuff, you actually have to go in and program in the hydraulic tree, make sure that we understand how that main line runs and how we need to split up that water use. So just be aware that this is going to be a step that needs to be taken right off of the bat with the OptiFlow or the 200 station 2-wire.
So one step further is looking at this map right here. I work on sites, cities, city parks that have multiple controllers and multiple points of connection to water. The beautiful thing about this controller system is that this controller system with OptiFlow can, each controller, say the 2-wire 200 station, can manage up to 4 points of connection to water. And as you mentioned, in the wireless cross-controller flow feature, we can wirelessly cross-controller flow with X amount of controllers over 40 different points of connection to water. So any size site, let's just say you have 3 controllers side by side, you need to share 1 flow sensor. Do you need to run an ISO-flow, separate water windows? Complicated? No. If you program the controller properly, let it go to work for you wirelessly.
Yep. Exactly. And that really speaks to the advantage of the cloud based features that we are building the backbone of WeatherTRAK on. That is exactly why we feel like the advantage of managing all of this information in the cloud makes it easier to manage, because there aren't CCUs out in the field. There aren't 100 different hardware components that manage the logic. The logic is all software, and therefore makes it easy to program and easy to manage, easy to troubleshoot.
And I've worked with many other systems with different points of connection for the communication side. As far as communication goes, having to troubleshoot that, getting the right tech on the site to troubleshoot, keep it simple. The cellular connection, it works. The cell modems in these controllers are excellent. We can talk about cellular communication, different towers, different gigahertz speeds for cell modems, whatever you want to talk about. My point is, this system, it just hasn't failed me going on since 2000 and been working with WeatherTRAK since 2015, and it's been the easiest to use so far. So I have nothing but good things to say through my experience.
That is awesome. Awesome feedback. Okay, so what I want to do now is very quickly double back. That ease of use in the hardware is something that I wanted to highlight. We started off talking about how it's easy in the software, but one thing that I like about the new 200 station 2-wire, the H2O, only available on the most recent hardware, the HydroPoint controllers, or the H2O 2-wire, is an upgrade path. So your customers who bought stations at 96, right? Maybe the beauty of 2-wire is that it's easy to expand. It can manage the challenges of a constantly changing site, and you can build on. You can just tack onto your main line and add a few more stations. Likewise, with WeatherTRAK, upgrading the hardware to go from 96 to 200 stations couldn't be more simple. And I'm gonna move my camera here for 1 second. Excuse me. Yeah. So here we are in WeatherTRAK Studios, and my super nerdy WeatherTRAK 2-wire demo. So I have this that you would appreciate. I built a miniature 2-wire system so I could test all of our decoders and test all of the programming logic. what I want to show you here is this was actually a 96 station 2-wire when I was using it before. When we came out with the 200 station, all I had to do from a hardware perspective is these little keys right here. When you get a H2O 2-wire, it comes default to 48 stations. If we add one of those keys, that bumps the configuration up to 96 stations. So that expansion was easy from 48 to 96 already. And the only hardware difference, other than the extra field components that it would take to run more stations out in the field, is adding that second key and then doing a firmware upgrade, right? The only hardware part is just plugging in that little glowing blue key, and the rest is firmware. And no, you've done this, right?
Yes.
Can you talk about your experience?
Yeah, I've done this on a job site in Roseville, California, where they had 3 controllers that were conventional wire, one that was 2-wire. And the best part about this system is with a simple key install and a firmware upgrade, we were able to go from 96 stations with the first controller to 200. We're using 120 stations there, ironically. And it was a simple upgrade. It took me about 5 minutes. So no complaints there. Best of all, this system was able to cross controller flow, 2 points connection for water, 4 controllers, no problem.
No problem.
The most important thing to this is, like I said before, going into this meeting, is the key to success is simplicity. So no pun intended.
Yeah, by all means, like that, and that really is our focus, right? That is what we want to highlight is this is something that is very, very manageable. It isn't a heavy lift from any perspective, whether it is the hardware or the software. It, for an experienced WeatherTRAK user, it should just simply expand the capacity and not add any extra burden onto learning new systems or learning new management. So we have done what I set out to do. We talked about why 200 stations, why the sweet spot for 2-wire was beyond what we previously offered. We talked about the upgrade path. We talked about OptiFlow standards. I also wanted to quickly highlight that there are some features that are on this new 200 station H2O platform that I love and I see making its way down to the smaller station counts, but currently only available on the firmware for the 200 stations. And that is some new alerts that are really starting to leverage our advantage. And by that, I mean whether the HydroPoint infrastructure of 2-wire provides what we call true bidirectional decoder communication. So we're not only sending signals out to that decoder, but we can collect information from those decoders and use that and be able to provide a higher level of analysis of your field equipment. And we start to see that unravel. We start to see some of the maintenance, I don't want to call it hardships, but definitely the headaches that come along with our current system is the resolution of the alerts. Right now on a H2O controller, all of these conditions that you see here would all come up as a no connect. So the current system does detect this, but it doesn't provide the resolution of information that the new H2O 200 station can provide, right? So if you have a decoder that all of a sudden goes missing, on our current system, that comes up as a no connect. But that can mean so many things that it's only a good starting spot. Now with the 200 station, we start to see not only a station decoder not found alert, which can mean something totally different than a solenoid that has gone bad or other things that might cause a no connect alert, as well as duplicate decoders. If you've had the experience of troubleshooting multiple decoders with the same address on our current platform, you will appreciate what a huge addition the new station decoder address conflict is, or that tells you basically, I've got two decoders that are programmed to station 5, right? I've got two number 5s out there on the wire path. What do I do about that? And that level of specificity really, again, eliminates a whole lot of chasing your tail when you're troubleshooting. So I only mention this because I think it shows the path of development that we're starting to leverage that true bidirectional decoder in a much more beneficial way to the managers out in the field.
And also to add to that, when the system is installed properly, say after, I always work pre-construction meetings with any 2-wire irrigation control sale. That's included in our sale from SiteOne Green Tech. And knock on wood, we've had great success in that regard. Also, when a system is properly installed, we have a no connection. With the right milliamp clamp meter, we can tell if there are no milliamps going to the decoder and or to the solenoid without taking apart any splices. So to diagnose these issues in the field, as long as you know where the decoders are, it doesn't take long at all.
Exactly. All right. So we are coming up. We are actually past on time. So I need to finish up with the standard question that I ask all of my first time guests. Noe, I ask everyone who comes on the show, what does WeatherTRAK save you?
WeatherTRAK saves me time. Most valuable asset that we have in this life is time. And WeatherTRAK systems make for installation and maintenance very streamlined, very efficient. And so far, of the many systems I've worked, this is by far my favorite for simplicity. It's just a simple system that has yet to fail me once. And if anybody needs to see proof, you're welcome to come out to California, and I'd love to walk you around.
Well, I'd love to go see some of your overseas projects. Those sound all right.
Republic, Lima, Peru, Key West, Florida, locally. I mean,
sounds like you're well traveled. Those sound like fun projects to participate in.
Just a bit.
All right, so real quick, want to talk about what we got coming up next week. We are going to highlight the WeatherTRAK support resources. We got a great manager from Brightview and out of Arizona. James Carr is a regional irrigation manager for Brightview, and he is going to come on and talk about some of his useful WeatherTRAK support resources. In addition, we're going to have our VP of customer support or customer service, Chris Mendiola, is going to join us and talk about all of the different ways that you as WeatherTRAK users can access what we have is a very large infrastructure of support resources. So we'll go into some details and best practices on that. In the meantime, thank you all for coming, and Noe, most of all, thank you for making time to do this with me this morning. I really appreciate not only your time, but your insight.
And also we have a question.
Oh,
200 zones are installing copper ground rods, surge protectors, or both. Can you speak on how many ground rods per zone? So through my experience, a great question. Every design is different. So this is for Adan Gonzalez. For Adan, grounding, through my experience, is easiest to say every average 10 stations, because every design is different. And it's critical to say every average 10 stations and or 500 linear feet of 2-wire. So consider you have a 1,500 foot length of 2-wire with no stations. To replace 1,500 feet in the ground would take a huge amount of time compared to 1/3, which is 500 feet. So it's subjective to a site. As far as grounding rods go, I also teach proper grounding. There's a huge difference between the sphere of influence of a grounding rod and a grounding plate. You work in streets, narrow medians, near sidewalks and buildings. Grounding plates are really the only way to go. Bigger areas, grounding rods are the way to go. Consider the soil you're disturbing to install a plate or a rod. We also sell products known as Power Set to give you the best connectivity to earth grounding. In closing, every surge protection decoder gets wired to the 2-wire path that gets wired with 6-gauge solid bare copper wire to grounding point. The premise is you have 14 2-wire. You need a bigger gauge wire to redirect a surge to the earth. So one of these days, Ben, let's talk about grounding.
Absolutely. I love it. And just from the WeatherTRAK textbook, we recommend every 600 feet or 5 decoders, unless you are in a lightning prone area. So in Florida, that shrinks down to every 300 feet because you guys are getting struck by lightning all the time down there. So definitely we will have another episode on another day about grounding, and I will have you back for that.
Sounds good.
Awesome. Looking forward to it. Thanks, Noé, and thanks everyone. We'll see you next week.
See you guys.